Hello, everyone. My name is Michaela Milliken.
Hi, my name is Donald Seckham.
So we are going to be presenting our experiment on the effects of mass on airtime. So for our theoretical background, some concepts that you might want to know about before we get into this experiment. The acceleration of gravity, which is 9.8 meters per second square. Airtime, which is basically the time the object spends in the air, and the equation is right there. And also gravitational force. So what sets our experiment apart from other groups? We utilize the Physics app, which enables students to recreate physics experiments at home despite a lack of resources and equipment. So because our experiment was very simple, we also had less likelihood for error. So for our design process, I'm going to run us through the procedure step by step. So first and foremost, you want to make sure that you are in a quiet environment. Next, download the app Physics on your smartphone. You're going to want to access the acoustic stopwatch feature on the app, and then enter a threshold value for the first parameter. And this is, you'll know that you have your first parameter when the ambient noise doesn't trigger the stopwatch. So next, you're going to set the minimum delay for the second parameter. And then getting into the actual experiment itself, we're going to want to fill an empty water bottle with metal bolts and screws, and then fill the rest with water to fill the remaining space. Now with a hook on the lid of the water bottle, you want to hook the bottle to the edge of a wooden board, and then hit the bottle with a wrench for it to free fall. Then you're going to record the time of the free fall using the acoustic stopwatch. The equipment that we used for this experiment was a smartphone with the Physics app, a 2x4 piece of wood, a metal hook, a plastic water bottle, a scale, and a pen. So essentially the question that we're trying to ask here is, what effect does a change in mass have on airtime despite the equation proving mass should not have an effect? The purpose of this experiment is to measure the duration of a free-falling object by timing the elapses between two loud acoustic vents. So I'm just going to play the video of our experiment. Okay, and now for our results.
The effect on mass versus airtime had minimal effect based on this graph. Everything was pretty much still constant. One thing you can probably deduce from the graph is that as our weight increased, our time seems to decrease, but in actuality, it stays pretty constant. It might have decreased because of errors within the system. The integrity of the system, I believe, was starting to get warped. But this graph shows that there's little to no effect based on the peaks, because our average time was to be calculated at 0.545 seconds, which most of these peaks reach that. They don't go over 6. They don't go below 5. So yeah, that's this graph. Yeah, so basically our conclusion is mass did not play a significant portion of contributing to airtime. And the equations for you'll see right here in this column that we got different times. Relatively the same though. Relatively to what we calculated, they should be the same. There were only 4 instances where they were exactly as we expected. Right here, it was expected time of 0.543, and our airtime that we recorded with phyphox is 0.545. Our theoretical equation data should match up with our experimental data, in which in 4 instances it does. And so that's how we can determine, that's how we can find correlation between our theoretical mathematical inputs and our experimental data. So everything outside of that, there was error, or there was inconsistencies within the system. For why the mass doesn't equate to much of anything is because gravitational force, force of gravity is mass times gravity equals gravitational constant times the mass of the Earth times mass. It's like a tiny mass versus the Earth, which doesn't amount to much, divided by the radius squared. And if you notice, the small masses on either side of the equation, they cancel out. So that's the component of why mass has no effect on the rate at which things fall. We're limited by changing the size of our container. So like we only had 22 attempts at this before the container was filled to capacity. You could probably change, like, because you couldn't change the shape of the bottle because then it'd affect the airtime, like by virtue of it being like more air resistant or less air resistant, I suppose. You can change the contents of the bottle by putting like more dense fluid, I guess. You could put, I don't know, fill it with like liquid metal or something and get more results that way. But we were limited to 22. Our uncertainty by virtue of us just thinking of what it could be without any numerical values, the delay between the sound entering the phone and being recorded and how phyphox gives you the time. This is just a natural delay. Also, some other components of the phone. The microphone could be dusty. My phone's not new that we used for this experiment, so there could be some issues with that. Also, I had mentioned that the metal bowl that this thing strikes to turn off the watch, the stopwatch, to get our time, it might have hit the edge of the parabola, which would change the height. And if that height changes, then our time changes. So that was also part of the uncertainty, is just the object itself falling into the metal tray and turning off the stopwatch. Future experiments. We could change the system itself and have it more rigid and more air resistant, like have more control within the system, but keep the concept the same. I had proposed maybe using a metal tube that had an opening where we could slide in the object and just have it drop that way, where you want to limit as much of the uncertainty and variables that enter into your system. So changing the rig would have helped. Not using wood for the platform, maybe using a metal sheet, a metal 2x4 or something would help. So that's how we'd use future experiments, change it that way.
Yeah, so that's our experiment. Thank you guys for listening, and have a great day.